So we can make use of the data given here to find the normal force and the acceleration of a block which is kept on a horizontal smooth table. This question, it is only given the initial velocity but the final velocity is not given, and hence the value of v is equal to 0. So what is f cos theta? It is 50 into cos 30 divided by the mass is 5 kg. Hello everyone, welcome to session 4 of chapter 5 Laws of Motion. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So today in this session we are going to discuss about the numericals which is from the chapter Laws of Motion. So here we begin with the first problem is a constant retarding force of 50 Newton. The force is retarding here they are saying, which is applied to a body of mass 20 kg moving initially with a speed of 15 meter per second. How long does the body take to stop? So we have to find the time taken by a body to stop. Here the question is the constant retarding force, that is F is equal to minus 50 Newton. It is a retarding force and hence with the sign minus 50 is applied to a body of mass which is equal to 20 kg. So the body is moving with the velocity 15 meter per second, that is u is equal to 15 meter per second. We have to calculate how long does the body take to stop, which means the time taken by the body to stop its motion. It is given that retarding force, mass and the velocity, we have to find out the time. As I always say, it is very important to make a note of the given data to find out the required answer. So in this question, it is only given the initial velocity but the final velocity is not given, and hence the value of v is equal to 0. To calculate t, we can make use of the expression v is equal to u plus at. But here we have no idea about the value of a, but that can be calculated by using f. How to calculate? By the expression f is equal to ma. So a can be calculated from this, that is f divided by m. So what is f? It is minus 50 and m is 20. So we will get the answer as 2.5 meter per second square. The value of acceleration is minus 2.5 meter per second square. So let us substitute the value of a here in this expression. We get v is equal to, what is u? That is 15 meter per second plus a t we have, but a is minus 2.5. So I can write it as minus 2.5 t. So we have the value of v is 0, which is equal to 15 minus 2.5 t, or we can write it as minus 15 is equal to minus 2.5 t. So from this we can write t is equal to minus 15 divided by 2.5 with the negative sign. So minus and minus will get cancelled and the answer for time is equal to 6 seconds. So the time taken by a body to stop is 6 seconds. This is how we can calculate the time by making use of the data given in the question. So let us move on to the next problem now, and the next problem is a block of mass 5 kg is kept on a smooth horizontal table and a force of 50 Newton is applied on it at an angle of 30 degree. Find the acceleration of the block and the normal force. We have to find out the normal force and the acceleration. Here it is given that the block of mass 5 kg is kept on a smooth horizontal table and a force of 50 Newton is applied on it at an angle of 30 degree. We have to find out the acceleration and the normal force. So let us analyze this condition like this. A horizontal block is kept on a smooth surface. So here the normal force acts and here the weight acts to the downwards. So this will be equal to mg and this is the normal force. And this force acting here at an angle of 30 degree. So here this force is resolved into two components, along x component as well as along y component. So along x component it is f cos theta and along y component it is f sin theta. So from this we can come to know that n is equal to f sin theta plus mg. So what is f? F is 50 Newton, sin theta is 30, so sin 30 plus the mass is 5 kg and acceleration due to gravity is 10 meter per second square. So what is the value of sin 30? It is 1 by 2 plus 50. So here we will get 25 plus 50 which is equal to 75 Newton. So this is the normal force. So they have even asked us to find the acceleration. So how to find the acceleration? From the expression f is equal to ma, we can write a is equal to f divided by m. So here the force component is f cos theta divided by m. So what is f cos theta? It is 50 into cos 30 divided by the mass is 5 kg. So what is cos 30? We can write it as 50 into root 3 divided by 2 divided by 5. Or we can write it as 5 ones are 5 tens are 10 into root 3 divided by 2, or we can write it as 5 root 3 meter per second square. This is the acceleration value. So we can make use of the data given here to find the normal force and the acceleration of a block which is kept on a horizontal smooth table. So let us move on to the next problem. The next problem is a body of mass 5 kg is acted upon by two perpendicular forces. One is 8 Newton and the other one is 6 Newton. That is F1 is equal to 8 Newton and F2 is equal to 6 Newton. Give the magnitude and direction of the acceleration of a body. We have to find out the magnitude and direction of the acceleration of a body. So let us now find the magnitude of the two forces, that is by taking square root of the square of the forces given, that is 8 square plus 6 square, 8 8s are 64 plus 6 6 are 36, which is equal to square root of 100 and it is equal to 10 Newton. Now we have to find out the magnitude and direction of the acceleration of a body. Here two forces acting are 8 Newton and 6 Newton and the acceleration of a body is, say for example, r. So we have to find out the direction of acceleration of a body as well. Say for example, theta is the direction of r with the force 8 Newton. Then theta can be calculated as tan inverse of 6 divided by 8. So what is tan inverse of 6 divided by 8? 6 divided by 8 gives us the value 0.75. So we have to find out the value of tan inverse of 0.75 by making use of a logarithmic table. In that you can go and check the inverse value of tan theta of value 0.75 and the answer we get here is 36.87 degree. So this is the direction of acceleration. So now we have to find out acceleration magnitude with the help of, we know the formula F is equal to ma and a can be calculated by the formula F divided by m. But what is F? It is the value what we have calculated, that is 10 Newton divided by the mass is 5 kg and hence we will get 5 ones are 5 twos are, so 2 meter per second square is the value of acceleration. So the next problem of the session is a bullet of mass 0.03 kg enters a block of wood with a velocity of 600 meter per second. It's the initial velocity of the bullet when it enters the block of wood, that is 600 meter per second, and penetrates to a depth of, that is 0.2 meter. Calculate the average force of the wood. We have to find out average force of the wood to the penetration of the bullet. So when the bullet penetrates the wood, what is the average force that exerted by the bullet when it enters to the wood? When it penetrates to the wood, we have to calculate. And here we have the data, that is mass of the bullet 0.03 kg and it is entering with a velocity of 600 meter per second and it penetrates to a depth of 0.2 meter. What is the average force? So how can we calculate the average force with the help of these data? So to calculate force, we must need the values of mass and acceleration. But the acceleration is not mentioned here in the question. How to find the value of acceleration? That is by the equation v square minus u square is equal to 2ah. The final velocity is not given and hence the value of v is 0 and u square will be minus 600 square, which is equal to 2a into the h value is 0.2. So 600 square gives us 36 4 zeros, which is equal to 0.4a, and the value of a will be divided by 0.4, which is equal to meter per second square. We have to calculate the average force, that is mass into acceleration. The mass is 0.03 and the acceleration is, the value we get here multiplying these two is 27,000 Newton. So this is the average force exerted by the bullet when it penetrates to the wooden log with a speed of 600 meter per second. So like this you can apply the formulae and the conditions what you have studied in the chapter laws of motion, and you can get the solution for many more interesting problems. I hope all of you will try with different examples. Keep learning, students, all of you. See you all in the next session. Thank you.